Okay, scientific notation, super quick, easy thing to do. You've all done it before, I know, probably in science class and math classes, and you got to be able to do it. They love this topic on the OGT test. There's always going to be one question on here. So, quick review, because we've got the positive numbers and negative numbers. We have to be able to go both ways. If you're asked to write a number in standard notation, we're given the scientific notation. Okay, remember, we're really just expressing a number as a power of 10, okay? So that's what this 10 times 10 to the fourth means. It means we're multiplying 9 times 10 to the fourth, which is really 1 with 4 zeros after it. So 10 to the fourth is really 10,000, and we're multiplying 9 times 10,000 is one way to think of it, giving me 90,000. Okay, most of us don't think of it that way, though. That's sort of the mathematical explanation. Most of us think of it as, this is telling me, this number, how many zeros I have to have added after the decimal point of my 9, which is really just after the number. So I start with a good old 9. There is no decimal point written there, which means it has to be right after the number, and I'm going to put 4 zeros after it. 0, 0, 0, 0. Move the decimal place 4 times, and I end up with a good old 90,000, which is exactly what we said over here. Okay, so that would be my first one. Now what happens if I have a negative power to my 10? Second one is 2.7 times 10 to the negative fourth. So what do? Anybody remember? Donovan, good. You're right. We move it the other way. So here, maybe I should have given myself a little bit more room here. Move this over. And instead of moving my decimal place to the right, as I did, because in this example I moved to the right each time, I'm moving it to the left, negative. Don't we think, if we think number line, on a number line, here's my number line, negative numbers, if this is 0, negative numbers are in that direction, positive numbers are in this direction. Same thing. So negative exponent is telling me to move to the left. So I'm going to move it 1, 2, 3, 4 times again. That's going to become my new decimal place, and I put in zeros wherever I just created empty holes. So there's going to be a 0, and a 0, giving me the actual number 0.00027. There is no decimal anymore between the 2 and the 7. Okay. Most people like to put a 0 at the beginning just to indicate that, hey, there is no whole number. I think that's the clearest way to represent that. Opposite, going the opposite direction, write each number in scientific notation, and we are literally reversing the process. Okay, so I'm given a decimal or not a decimal. In the first case, I don't have a decimal place in that number. That means it's at the end. I want to write it in scientific notation, which means I want 1 digit to the left of the decimal place. That's it. So I want a decimal place, 1 digit. It's going to have to be the first digit, which is an 8. So it's going to be 8 point, and then I can have as many digits as I want after that. So I need to get this decimal over to right after the 8. I have to move it once, twice, 3 times, 4 times, 5 times to be right after the 8. So 8.7 times 10 to the 5th. 5 because I moved it 5 times. Let's try another one. This one, I'm moving it to the right. 1, 2, 3. Again, I only want one number. That's going to be the 1. Anything else that's significant has to come after it. So I've got a 0 and a 9. Because I can't just forget about that 9. The 0 is a placeholder, so I do have to actually include the last 3 there. Times 10 to the, you moved it 3 times. This time we moved it 3 times to the right. So I'm going to put a -3 for my exponent. Okay, those are examples for scientific notation. Good luck.